Continuing on in section 1.4, in problem 3, reasoning and properties were used to show that two expressions are equivalent. This is an example of deductive reasoning. Deductive reasoning is the process of reasoning logically from given facts to a conclusion. To show that a statement is not true, find an example for which it is not true. We only need to find one statement that is false for the whole statement to be shown not true, and we call this false statement a counterexample. So, in example 4, we're going to figure out, are these true or false? If it's false, we're going to give a counterexample. So if we first look here, a times b equals b plus a. That's not one of our properties per se. The properties that we've dealt with are multiplication on both sides or addition on both sides. But let's plug in some numbers and see what happens. So I'm going to pick some numbers here. It doesn't matter what numbers you pick. Okay, doesn't matter which numbers we pick. I just picked a to be 2 and b to be 3. So I'm going to plug those in. 2 times 3 equals 3 plus 2. 2 times 3 is 6, and 3 plus 2 is 5. 6 does not equal 5. So since this is false, the entire thing has to be false. And my counterexample is right here. If a is 2 and b is 3, and we plug those in, it shows that 6 does not equal 5. So this is not true, it is false. If we look at b, a plus b in parentheses and then plus c equals b plus the sum of a and c. Well, if we look here, this does look pretty similar to some of our properties. We have an a b, and a c on each side. Here, they've been grouped differently and commuted, so our associative and commutative property were both used, but it looks like it'll be true. Let's plug in some numbers and check. So I'm going to try A1, B2, C3, for example. 1 plus 2 plus 3 equals 2 plus 1 plus 3. Let's check. 1 plus 2 is 3, plus 3 gives me 6. 1 plus 3 is 4, plus 2 is 6, so 6 equals 6. So we thought it was true, and it shows from our example that it's true. We could try other things to check and see if there's any that don't work, but this is just using our commutative and associative properties, so we should be good there. Now, is each expression true or false? If it's false, give a counterexample. For all real numbers, j and k, j times k equals the sum of k plus 0 and sum of k and 0 times j. Well, using our properties, we know that k plus 0, anything plus 0 is just itself. That's our identity property. We also know that j times k equals k times j with our commutative property of multiplication. So it looks like this is going to be true, but let's plug in some values and check. So for j, I'm going to pick 4. For k, I'm going to pick 3. So I have 4 times 3 equals 3 plus 0 times 4. I get 12 on the left. On the right, 3 plus 0 is 3 times 4 gives me 12. So I get 12 equals 12. It checks. It's true. And again, just because one thing works doesn't mean that everything will. So check your properties as well to see if it seems to make sense, if it seems reasonable. For real numbers m and n, m times n plus 1 equals m times n, and then plus 1. I don't think this is going to work. It doesn't look like any of our properties, but we can double check by trying some values. So I'm going to say m equals 5, n equals 6. 5 times the sum of 6 plus 1 equals the product of 5 and 6 plus 1. So parentheses first give me 7 times 5, 35 on the left. On the right, we multiply first, then add 1, I get 31. So since I found an example that's not true, this is my counterexample, and this is false. And as far as my counterexample goes, I can just show this step right here. Quick recap here. Relationships that are always true for real numbers are called properties, and those are rules used to rewrite and compare expressions. Important properties include the commutative, associative, and identity properties, the zero property of multiplication, and the multiplication property of -1. And that's all I have for section 1.4.